Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to continue from lesson 2 of sequences and series of relative maths. Okay, lesson 2, we looked at the summation notation or the sigma notation. And we also looked at the relationship between S sub n and U sub n. And we used that relationship to find U subs, meaning particular U's. Okay, meaning particular terms. Okay, in today's meeting, we are going to look at a special situation. Okay, special situation in the sense that the sequences that we will be working on or will be dealing with, the sequences will not be AP, okay, GP. So neither an AP nor a GP. Whenever you have such a situation, how do you deal with that? Okay, so indirectly, we are going to look at our last two types of sequences. Remember, I told you that we'll be looking at 4 types. The AP, which is the linear sequence, the GP, okay, which is the exponential sequence, then the quadratic and the recurrent sequence. Okay, so indirectly, we are going to have a look at maybe 1 or 2 questions on the quadratic sequence. Okay, then after that, we move on to that of what? Of the recurrent sequence. So our main lesson here is supposed to be for recurrence or sequence. So by the end of today's meeting, you should know how to identify recurrent sequence and how to use recurrent sequence to find particular terms. Okay, and therefore, okay, use that generated sequence, okay, to find your U sub n. Your U sub n. So we'll be looking at how to find the U sub n of a recurrent sequence, just as we know how to find the U sub n of AP and GP. Okay, we should know how to find the U sub n of recurrent sequences. So that's all that we are going to do, okay, this afternoon. So quickly, let's look at the solution to this question. In any case, what are the questions? Find U sub n in terms of n in the following. So usually, we are comfortable working with AP. We know how to find, okay, the U sub n for APs, U sub n for GPs. So let's see whether these sequences will satisfy, okay, these two comfort word zones in terms of the sequence. So let's look at the first one. Okay, do we have a common difference? So we are looking at the solution. Let's look at the solution to the first one. Please, okay, I'm writing solution first. Again, in terms of n, so underline. So it means until your result is only in terms of n. You don't end there. That is your U sub n. So solution, question A. I'm going to extract. So the sequence is 1, 9, okay, 25, okay, 49, comma, then your ellipse is very critical. Okay, so an infinite sequence, so you extract them as such. Okay, so the question is, the sequence that we have here, is it an AP? Is it the whole class? Test whether it's an AP.
Sir, please, it's not an AP.
It's not an AP. Okay, so check again. Is it a GP?
No, please.
It is not. So remember, okay, I told you that if your sequence is not an AP, it doesn't automatically mean that it is a GP. And this is a situation that, okay, addresses that fact that I made. Okay, so now this is not an AP, it's not a GP. So how then do we find, okay, the U sub n? Okay, and this is all that we are going to do. Okay, now the first difference, let's look at the first difference. And by that, this is what I'm going to do. So I'm going to write this first difference. Okay, moving forward, you know, this is the first example. So I'll refine the presentation, so take notes. So first difference, meaning I'm finding the difference between consecutive terms. The first, okay, difference here, 9 minus 1 will give you 8. Do you agree?
Yes. Yes.
The second difference, I'm waiting. 25 minus 9, I'm waiting. Give me the value.
16.
16. Okay, 49 minus 9, minus 25, sorry.
24.
24. Okay, you know there will be other consecutive terms that we have ignored. So it means the difference will also give us a sequence. Okay, but the sequence will also be an infinite sequence. So I have a sequence of difference. Can you see that?
Yes, please.
Yes.
Now let's determine, you realize that the original sequence, it was neither an AP nor a GP. Now let's look at that of what the sequence of difference. Okay, so check whether it's an AP.
It is.
It is an AP. Please, do you all agree?
Yes, please.
Okay,
Yes.
so your sequence, of difference is what? An AP. And how did you get your sequence of difference? You came to find another difference, is that not it? So I am going to call that one second difference. Is that okay?
Yes, please.
Okay, so what am I writing? Okay. All right, so give me. All right, okay, so the difference gave us, okay, we said it's going to give you 8. 8, am I right?
Yes.
8.
Yes.
Okay, so you can see that here, okay, there exists a second common difference. Do you agree? The first difference was not common. So your sequence of difference, first difference, you had 8, 16, 24. Okay, but here you have what? A second difference being common. So your sequence here has a second common difference. So please listen. Okay, you have a fair idea in terms of mapping. So I will handle it from the mapping perspective. Then after that, we come to that of what? The sequence perspective. The one that you can relate, then you work with it. Because here, all that we need is our U sub n. Okay, so this is it. Here, since there exists a second common difference, if there is a first common difference, then your sequence becomes linear. Okay, if there exists a second common difference, then you move from linear to quadratic. Is my point well made?
Yes, please.
Hello, are you with me?
Can you come again?
Okay, I said, if you have a sequence and there exists a first common difference, meaning if you find your given sequence, if you find consecutive differences or differences between consecutive terms and you get the same value, then it means your first set of difference will give you the same value. So you have a common difference, is that not it? And whenever you have that situation, you know that the sequence is linear, which is the same as the AP. That's why you go and write, this is an AP. For an AP, you get it?
Yes, please.
Now here, we didn't get first difference because the first differences gave us 8. The first difference gave us 8. The second difference gave us 16. The third difference gave us what? 24. We did the ratio 2. We didn't get the same, ratio. So it means neither an AP nor a GP. But keep your sequence of differences, which gave us what? 8, 16, 24, meaning keep your differences between consecutive terms and use it to form a sequence in that order. So that will give you your sequence of difference. So our sequence of difference here will be 8, 16, 24, coming from the difference between consecutive terms, then ellipses. Then we go and find, okay, so it's like now, this will be the sequence that we are working on. But in this sequence, again, you subject it through, is it an AP, is it a GP? So let's test AP. Difference, 8. Difference between this 8. So you can see that you have a common difference. Do you agree?
Yes, please.
So it means this time around, you can see that I labeled this one as my first difference, but it wasn't common. This one is my second difference. So I'm saying that it is common. So I have, a second common difference. Is that okay?
Yes.
Is my point well made? Now I said, if your first difference is common, then your sequence will be, what do you call it? Linear. But if it is what? Your second difference, that is a constant, that is the same, meaning that is common, then your sequence is going to be that of what? Of a quadratic one. So, or it will be of quadratic nature. You remember, linear, the power is 1 of your S. Okay, what do you call it? Quadratic, your power of the x is 2. Okay, so in this case, this is all that you are going to write. So in terms of mapping, I'm going to use mapping to drum home my point, like I said. When you get it, then I move to sequence. Okay, Prof. Karen.
Can you repeat when it is a quadratic again?
I said, if you get a second common difference, okay, so meaning, okay, your first difference, you come and find a second difference. If the second difference is what common, then it means your sequence will, its rule will be of what? The quadratic nature. Is that clear?
Yes, please.
Okay, so now we've realized that there is a common difference, however, a second common difference. So your rule per mapping, okay, mapping would have said, this is the situation, would have said, okay, y will be equal to a s squared plus what? bx plus c. That will be the nature. Remember, if your mapping, there is a first common difference, then its nature will be y is equal to be linear, ax plus b. You remember? Okay, unless you have not done mapping, even in JHS you did this, where you go and find a and b are constant to be found. So you take x and its corresponding y, you substitute. Take y and its corresponding x, or x and its corresponding another y, a different one, you substitute. Because you have two unknowns, you need to generate two equations that you solve simultaneously for these two unknowns, a and b, then you know the general form of the rule for that mapping. Okay, however, here, okay, quadratic, it will be of this form. How many unknowns can you see here? 3. So, okay, like I said, for the two unknowns, it means with this one too, you need to generate 3 equations and you will solve them simultaneously. So you can indirectly see the volume of work. Is my point well made?
Yes, please.
Yes.
Okay, so this is it about what? The mapping perspective. Now I'm taking you home, meaning what we are doing sequence and series. So this is what we are going to do. Now I'm going to write this. Anytime your sequence is not an AP, it's not a GP, this will be the nature of the U sub n, the formula for the U sub n. So U sub n, take notes. I will write this one when we are looking at recurring sequence, I will make use of this part as well. Okay, so this is it. Your U sub n will be equal to A plus S sub n minus 1. Okay, where, take note, A is equal to the first term of your original sequence. So should I continue? I will come down. Okay, it's equal to first term of original sequence. Original sequence is the given sequence. Is that clear?
Yes, sir.
Okay, and S sub n minus 1. Okay, is equal to the sum of the first, okay, you know, this will be the sum of the first n minus 1 terms. So the sum of the first, okay, n minus 1 terms of a sequence, but the sequence will be your sequence of difference. So of, okay, the sequence of difference. I will throw more light on it, don't worry at all. It's so easy when you get the concept. It's so easy and it's interesting how, okay, the formula works. Okay, so this is it. So your A here is the first term of your original sequence. So if you look at this, what do you think will be your A?
1.
1, because this is the original sequence, 1. And S sub n minus 1 here, it is not the S sub n minus 1 of the original sequence. It's the S sub n minus 1 of your sequence of difference. And this is the sequence of difference. Is that not it? Hello, are you with me?
Yes, please.
Okay,
Yes.
okay. All right, don't worry. It is just a formula that I'm walking you through. So now this is what we are going to do. As you mature, you don't write this. So you don't write this. Okay, you should know what A is. You go and pick it. You should know how to find S sub n minus 1. You go and look for it. Then you come and substitute. So here I will say that that's A is equal to, okay, 1. That is the first term of the original sequence. This is the original sequence. The original sequence, remember I said, is the given sequence. And this is the given sequence. And what we have here, okay, is what we are calling the sequence of difference. Let me write S sub D to represent sequence of difference. So this is your sequence of difference, 8, 16, 24 ellipses. Is that okay now?
Yes.
So that's your sequence of difference. Now, okay, we need to find S sub n minus 1 of the sequence of difference. Okay, but you know, before you can find S sub n minus 1, you have to know S sub n, which is your parent, okay, function for S, okay, I mean for the sum. Just as if you want to find F sub in terms of function, if you want to find F of anything, you have to know F of S, which is your parent function. You get my point?
Yes, please.
But this n, the sum here is with respect to your sequence of difference. And we just said that the sequence of difference is what? It's an AP. Do you agree?
Yes, please.
Okay, so now I'm going to write this. I'm going to write this, okay, okay, sequence of difference. Oh, sorry, of difference. As you mature, I will give you the matured presentation. This is the first one, so I'll write a lot, obviously. So sequence of difference we know is equal to, okay, or you can put a column there, 8, okay, 16, 24, okay, ellipses. But our sequence of difference is an AP. We've done that, okay, we've done that, but this is an AP. Just follow, don't write, just listen, okay? When you get the understanding, I'll give you time to write. Okay, this is an AP. For an AP, okay, remember we need to find S sub n of this AP before we can find S sub n minus 1. For an AP, what is S sub n? Do we know, remember you have two formulas. Do we know the last term to use A plus L?
No.
No, so it means we put our usual n over what? 2 into, help me, 2a plus
2A.
what? N minus 1d.
Yes,
I hope you are following my professors.
Yes, sir.
Yes, please.
Okay, now if this is S sub n, okay, you know, do you know your A? Do you know your A? What? Okay, you can see that the A here, there is a conflict between this A and this A. Is that clear?
Yes, please.
So usually this is my advice to students, okay, to distinguish between these two A's, okay, because here you are talking about the sequence of difference. Give the A here a sub, so maybe A sub 1, or you can use A sub D, just to represent the sequence of difference, the A for that. You get it?
Yes, please.
Okay, this is the first one, like I said, so it will be deficient. I will write more sometimes, then maybe it will not be, the presentation will not be as nice, and I did that is expected to be. But don't worry, we'll, okay, shape things up as we move on. So here, I know that my A is from the sequence of difference because I'm now looking at this, okay, sequence. So the original sequence, all that you do with it is to use it to find the sequence of difference, and you use only the first term of it, that's all. Apart from that, you won't use anything. So at this point, okay, A we know is 8, sorry. A is 8. So what would D be? D is also 8, am I right?
Yes, please.
Yeah.
Okay, now, if so, I can say that this implies that, so but A is equal to 8, and what? Okay, D is also equal to 8. We've done the common difference. So if you like, you could have done the rough work here, but in any case, we did it here. Going forward, that's what we will do. Okay, so at this point, I can say that, okay, this implies that S sub n minus 1, okay, will be equal to, So here now, this is S sub n. S sub n minus 1 will mean wherever I see n in this formula, I write n minus 1 there. Is that clear?
Yes, please.
Should I come again or my point is well made?
Well made.
Well made. So I'm going to get n minus 1 all over 2 because that is my new n. Then into 2a, a is what, 8, you said. Okay, or we agreed. Okay, then plus your n is n minus 1. So I'm going to get n minus 1 minus 1. Do you agree?
No, please.
Okay, this
Yeah.
n, what is? You can see. Okay, the person who said no, let me identify you or identify yourself so that I'll know, I'll mention your name and after that. Adoma, are you the one?
Yes, please. Please,
Okay.
as in no, as in you are wrong, but it has to be in a bracket.
No, as in
As in the other n minus 1 is supposed to be in a bracket.
this one.
Yes, please.
Okay, I'm matured. Okay, I was presenting it the matured way. So if I ignore the bracket, it will not be costly.
Yes, please.
You get it? But like I have advised, you can put it in bracket. Is that okay?
Yes, please.
Okay, all right. So if you know that, then, okay, in bracket, I close because my n here is now n minus 1, then minus another 1. Okay, this should also come. So my new n, then times my d. My d, we all agreed we had 8. Is that clear?
Yes, please.
Okay,
Yes.
so we are going to simplify this sort of. And yeah, deal. It's just the algebra. I've told you the relative math sequences and series, okay, contains a lot of algebra situations. So now we are going to get n minus 1 all over 2. Okay, then let's go and simplify what we have in the bracket. So this will give me, I'm removing the inner brackets. So I think this one will not go. Okay, so it means I can still maintain my square bracket, but this one will go. So that will give us what, 16. Do you agree?
Yes, please.
Then plus n minus 1 minus 1, and that will give you n minus 2. All correct.
Yes, please.
Then times your 8. My professors, I hope you are following.
Yes, sir.
Okay, very good.
Yes,
So
please.
now can I say that this will be equal to n minus 1 over 2. I'm still working on what we have in brackets. So this will give us 16 at normal circles. I'm going to remove the bracket here. So this changes to the normal bracket. However, if you use a square bracket, don't change it, maintain it, just for your work to be a little neat. It will not change anything, is that clear?
Yes, please.
Okay, so this time this will give you plus, okay, 8n. Then this time this will give you minus what? 16, am I right?
Yes, please.
Okay, so I am using the normal one. We are not done, so let's move on to, so we are not done simplifying what we have in bracket, then after that we expand. So let's move on to the next one. Let me see if I can rely on what we have here. So n minus 1, if someone, okay, so you know that this minus 16 and the 16 here will go. So I'll get n minus 1 over 2 in bracket 8n. Do you agree?
Yes, please.
Okay,
Yes.
so that's what I'm going to equally write. Okay, so let's go. N minus, so that will be equal to, say, I know I'm looking for S sub n minus 1. And that will be equal to n minus 1 over 2, then times what?
8n.
8n. Oops. Okay, so that's what we have. So at that point, what do we get? Okay, we know. Let me close this. Okay, you know the 2 can go here. Is that not it?
Yes,
Yes,
please.
please.
Okay, so in effect, I'm going to get n minus 1 in brackets, then times 4n. Do you
4n.
agree?
And
Okay, which gives us, we are going to expand. So 4n squared.
4n squared
Okay,
minus
minus
4n.
4n. Is that clear?
Yes, please.
Okay.
Yes, please.
Remember, so now, okay, all that it is because of un that we are struggling like that. Oh, use up n. Okay, we know one of its terms. The first term, that one, it will always be given because you take it from the original sequence. Okay, and the second term is S sub n minus 1, which will come from, we said, your sequence of difference. So now you know your 2 parameters for you to find your U sub n. So I'll write, therefore, my U sub n will be equal to, we said A, which is the original what did we stated the value of A? A is 1. Do you agree?
Yes,
Yes, please.
So we will substitute the 1. What you have there is only S sub n minus 1. It is not U sub n. Please take note. What we found here. So it will be 1. Okay, then plus your S sub n minus 1, which is this. Do you agree?
Please.
Okay, so that will give us 4n squared minus what? 4n. But you know that this is quadratic. So you have to arrange it in decreasing powers of what? Of n. So I will have this to be equal to 4n squared minus 4n plus 1. Okay, and obviously you can see that the sequence here, its rule is of what? Quadratic what nature. So it is coming from what? A quadratic what sequence. Okay, we'll do more, so don't worry. Okay, it's not difficult. Like I said, it's just a little technical. Okay, once you know the sequence of difference will either be an AP or a GP. Okay, as for your original sequence, it will neither be an AP or a GP. But your sequence of difference, okay, will either be an AP or a GP. And we all know how to find S sub n of an AP, S sub n of a GP. So if your resultant sequence of difference is what? An AP, then you find S sub n of that AP and use it to find S sub n minus 1. If this a GP, you use the formula for finding S sub n of a GP. Once you get that one, then you know, okay, the S sub n minus 1 of that GP. Then you go and add it to the first term of the original sequence, and that will give you what do you call it. So let's test and see whether it will satisfy, because we said this is the rule. Okay, it is none of your business to test, but I want to see whether this is indeed is right. So let's see whether the first term, so U sub 1, we are testing. U sub 1 means n will be equal to 1. So it will be 4 into 1 squared minus 4 into 1 plus 1. So this gives us what? Because it's my rough work, I'm writing 2 equal to's on the same line. So that will give me 4 times 1 squared is what? 1 times 4. So that will give me 4. Okay, then minus 4, then plus 1, which is equal to 1. So it's the same as the first term here. Can you see? Hello, do you get my drift?
Yes, please.
Oh, your voices are down. Am I scaring you? As a series and sequence that is scaring you?
No, please.
Okay, all right. So let's test that of the second term. So U sub 2 will be equal to 4 into 2 squared minus 4 into 2, then plus 1. So this will give us 2 squared is 4. 4 times 4 will give us 16. Okay, then 4 minus 4 times 2, 8. Okay, then plus 1. Okay, 16 minus 8 will give you what? 8, then plus 1, which is equal to 9. Is it not the same as the second term?
Yes, please.
Okay, so this is it about the quadratic, okay, what do you call it, sequence, and how to find its rule, which is the U sub n. And once you know U sub n, you should be able to find, okay, what do you call it, U sub anything. Okay, so that will be it. Let me see whether I created another rule. Okay, so at least I can do one more. So I'm going to continue with the B. Hello, are you with me, my professors?
Yes, please.
Okay, so let's look at the B and see what will happen in the B situation. So B, what sequence are we giving? 4. At this point, I will handle it maturely. So take note. Okay, Prof. Adoma.
Mr. Hackman, please, I thought you said you let us write the previous one,
Which previous one?
the A.
So write it. You mean this?
Yeah, like
I said you should listen. I'll give you time to write. Is that what you mean?
yes, please.
Okay, so maybe that time is not now.
Okay.
Okay, so let's continue. Okay, I will give you a better presentation so that when you are writing this one, you can equally take out what you can take out. Is that clear?
Yes, please.
All right. Okay, so Prof. Amma.
Mr. Ackman,
Yes,
please, could you go back to the previous page?
Hey,
Said you wrote, but Z is equal to 1.
but
I want
Z,
to know.
it's not Z, oh, please, it's A. You want to tell me that my handwriting is not legible, I won't mind you.
A. Thank you.
Okay, we quoted this, so but A is equal to 1, which is this. And we went to look for the, what do you call it? S sub n minus 1. So this is A. Okay, it is not Z. Is it clear now?
Yes, please.
Okay, all right. So I guess now I can move on. Okay, all right. If you get this, the work is going to be very easy going forward. Okay, so now let's go. I mean, when we get to the recurrent sequence, so 36 ellipses, then 64. Okay, so 64 ellipses for you. Okay, so this is what you have. Okay, so please verify for me, check whether this is an AP. Is it an AP?
No,
No,
please.
please.
Okay, is it a GP?
No, please.
Okay, so until today, okay, we would have been stuck. Okay, we didn't know what to do. Maybe you will say that the U sub n does not exist. Okay, it doesn't exist because your scope of knowledge does not cover that. But now you know the fact that it's neither an AP, okay, nor a GP doesn't mean the U sub n will not exist. Okay, to exist only that you find it, okay, with a different, okay, from a different angle, a different formula. Okay, so here, this is what we are going to do. Okay, we are going to find the sequence of difference. So I am going to write S sub D. So sequence of difference. So this is what I'm going to write, sequence of difference. Okay, and what will the sequence be? Find the first difference.
12.
Okay,
1,
comma, your second difference.
20,
20, comma, your third difference.
28.
28, then comma, your ellipses. Is that clear? Once this is infinite, your sequence of difference will also be infinite. Is that clear? But usually, because of space, that's why usually if I write sequence of difference, I will write in brackets S dot D. Not standard deviation. I've defined my sequence of difference so that when I'm going to, okay, use or where it will be required for me to write sequence of difference, that's long term, I will just write SD, and the person should be able to relate because I've defined what SD represents. Is that clear?
Yes, sir.
Okay, so very good. So this is what we have. Okay, now let's go and determine the nature of our sequence of difference. So let's see. Okay, let's find the first difference. I mean, from this, the difference here. So 20 minus, okay, 12 will give us 8. Am I right?
Yes, sir.
Okay, then 28 minus 20, that will also give us 8. So we have, okay, your sequence of difference is what? Is an AP. Do you agree?
yes,
Okay,
please.
so I'm going to write this is an AP. Okay, hold on. Now, what am I looking for? I'm looking for U sub n. Is that clear?
Yes.
Okay, so here, you know, your U sub n is given by, we said which formula for sequence of this nature, neither APGP, we are going to get A plus S sub n minus 1. I hope you are with me.
Yes, sir.
Okay,
Yes,
so, okay, but our A, we know, so now I'm not going to write it. Our A, we said, will be the first term of the original sequence. Is that not it?
Yes,
So in my mind, or in our mind, we know that the first term of the original sequence. So what do you think will be the value of A?
4.
4. Okay, and we need to go and look for S sub n minus 1. But before you can find S sub n minus 1, okay, you need to know S sub n of which sequence? this S sub, okay, of the, okay, the sequence of difference here. Do you get it?
Yes, please.
So this sequence of difference is again an AP, is that not it?
Yes,
Okay,
please.
so I am going to write, okay, that's, I will quote the formula straight away, basically. So that's, oh, sorry, I've written that already. Forgive me. Okay, so I don't have to write that again. So give me, okay, otherwise it will be, so let's go. Okay, so in this case, I'm going to get, okay, my S sub n, okay, will be equal to, so n S sub n, because I will need that to find my S sub n minus 1. So S sub n, because the sequence here is an AP, we'll put the formula n over 2, okay, into 2a, and remember the a, I said give it a sub d, for you to know that is the a of the sequence of difference, or you can give it a sub 1, just to distinguish between the two terms, that's all. I mean the two a's, for to avoid conflict, that's all. Otherwise, okay, you can leave it there. So now, okay, into n minus 1, okay, times d, all correct.
Yes, please.
Okay, so I'm matured. So I know my S sub n minus 1 will be equal to n minus 1 over 2, then 2 times my a sub d. A sub d is 12. Okay, so I'm going to substitute that one there. Is that clear? Please, am I moving fast?
No, please. It's okay.
It's okay, all right. Okay, then plus, your yes came late. Okay, so then plus n minus 1. The n here is now n minus 1. So per experience, we know you are going to get n minus 1 minus 1. Okay, so that will give us n minus 2. We are matured. You get it? Otherwise, you will just put n minus 1 in brackets, then minus 1, then later come and do this. Then your d gave you 8, so times 8, then you close it. All correct.
Yes, please.
Okay, so now this will be equal to n minus 1 over 2. Okay, then you go and simplify what we have here. So this will give us 24, am I right? Okay, then minus or plus 8n, then minus 16, all correct.
Yes, please.
Yes,
Okay,
please.
under normal circumstances, this should have been the normal bracket, but because I started with this, okay, I didn't want to dirty my work, so I used the close bracket, okay, to close it as well. So now I know, okay, n minus 1 over 2. This now will give us 24 minus 16 will give us
8.
8. So it will be 8 plus 8n here. Do you get it?
Yes, please.
Yes,
So
please.
my next step, that's what I'm going to do. So I write my S sub n minus 1 is equal to, okay, n minus 1 over 2. Then we said you will get what? 8, okay, minus 8n or plus 8n. It's plus. Okay, so plus 8n. Is that clear?
Yes, please.
Okay, so obviously you know that you can factor out a number here, okay, which this can reduce. Is that okay?
Yes, please.
Okay, so it's just algebra. So this will be equal to, please try and follow. If you are not getting it, let me know. Okay, all right, so we get, I'm going to write this as n minus 1 over 2. Okay, okay, then I will put this in brackets. I'm doing something here. I want to factorize this one too. So if I factorize that one, 8 will come out. Okay, then I will get what? Hey, help me.
1 plus n.
1 plus n. Very soon I will tell you something to do here, okay, which will be better. So this will go here 4. So I'm going to get n minus 1 in brackets. Okay, then 4. Okay, then into 1 plus what? And do you get it?
Yes.
Okay, however, okay, I'm going to clear this and tell you the best way to deal with it. When you are bringing out a factor, don't factorize completely. Bring out the factor that will cancel this. So bring out only 2. Is that okay? Other than that, here after that, you are going to multiply 3 factors. This, and that. But if you bring out only 2 and you cancel, you'll be multiplying 2 factors. You get my point?
Yes, please.
Okay,
Yes.
so that will be better. So I'm not going to cancel this entirely. I'm going to circle it for you to know that it's not okay. There is a better way to deal with it. So I'm going to deal with it the better way. So this will give me n minus 1 over 2, okay, brackets. Then I'm going to factorize this. Okay, let me bring the 2 at the other end. So that will give me, if I bring 2 out, this will be 4 plus 4n. Then my 2 will be out. Is that clear?
Please.
You can also bring the 2 here if you like. So this 2 will cancel this 2. So in effect, we are going to get n minus 1 into what? 4 plus 4n, which is a little prettier than this. You get it?
Yes, please.
Yes,
So
please.
now what do? We go and expand and combine like terms, if any. So this will give you this times that, which will give us 4n. This time that will give us plus 4n squared. Okay, this time that will give us minus 4. Okay, this time that will give us minus 4n. Am I right?
Yes, please.
Okay, so if you look at it, this 4n and this 4n will go. Do you agree?
Yes, please.
So in effect, you'll be left with 4n squared, okay, minus 4. Are we all fine?
Yes, sir.
Okay, is this your u sub n?
No, please.
No, until you add 1, sorry, the first term of your original sequence, you will get this as your u sub n. So now I know all my parameters in u sub n. So therefore, my u sub n will be equal to, remember we said a, and we got our a. A was 4, so we are going to substitute the 4. Okay, so a, which is 4, plus your s sub n minus 1, which give us its simplified form to be this. So that would be 4n squared minus 4. Okay, so in effect, I'm going to get, this will also cancel that. So my result will be equal to 4n squared. It is still quadratic. Am I right?
Yes, please.
Okay, so let's investigate. I've told you it's not your business anyway, but because this is the first example, we want to see whether indeed what we have there is it's not by fluke. Okay, what we have here is supposed to be the rule, or yes, for the u sub n, or indirectly the rule for the mapping. So if you were dealing with mapping, then the rule would have been y is equal to 4s squared. Okay. All right, so in that case, okay, let's test and see. Maybe we'll do it for the first one. Okay, u sub 1 would be equal to 4 into 1 squared. 1 squared is 1 times 4, and that will give you 4, and that's the same as the first term there. U sub 2 give us 4 into 2 squared. 2 squared is 4 times 4, and that will give us 16. So indeed, what we have here is, okay, the formula for the u sub n. Safa.
Yes, please.
Okay, now let's see what will happen. Let me check. Okay, all right. Okay, so let me see. Maybe going forward, we'll do this. Okay, I think, okay, in the recurrent sequence, we'll have situations like this. Okay, and I will explain that. Here, okay, your sequence of difference will not be an AP, it will be a GP. So it will basically be the same thing. You put the formula for, so when, okay, if this, let me go back. If your sequence of difference was a GP, then your S sub n that you are quoting here, you quote that of the GP and use it to find your S sub n minus 1. So whenever you see S sub n in your sequence of GP, okay, then you put n minus 1 there. Okay, you get there, don't worry. But now, okay, linear, we are fine. And I said we'll treat the exponential sequence of difference, okay, in the recurrence. Okay, so now let's look at our next concept, which indirectly is what our last type of sequence. So quadratic also catered for. We've done 2 examples under quadratic. Here, forgive me, I told you I'll give you time to write. So this is the time for you to write or capture. Capture, I mean, will be better. Okay, recorded. All right, so now we are going to look at our last type of sequence, which is the recurrence or recurring sequence. Okay, so I read, this is a sequence defined by a relation connecting between 2 consecutive terms. Okay, in actual fact, it should be connecting 2 consecutive terms or a relation between 2 consecutive terms. So I wanted or, okay, or between 2 consecutive terms. So take notes, all right. Okay, so here, very critical, 2 consecutive terms. Very critical, between 2 consecutive terms, very critical. Okay, such relations are of the form u sub n plus 1 is equal to a plus b u sub n, where a and b are constant. And your n, so indirectly, I'm looking at integral values of n again. So your n should be, okay, whole numbers, positive whole numbers. So we have 1, 2, 3, 4. You cannot be 1.5, okay, 2.5, what have you? Take note. There will be, okay, positive integers. Okay, example, u sub n plus 1 is equal to 3 plus u sub n. So if you look at this, okay, if you compare, your a is 3, your b is 1. Can you see that? If you compare this form with what we have here, your a is 3, and your b is the coefficient of u sub n, which is 1. Is my point well made?
Yes, sir.
Okay, and again, I will throw a little more light when we move on. So u sub n is equal to 2 minus 3, okay, u sub n minus 1. So if you compare, this is not n plus 1, but don't worry, it's u sub n, okay, sub n, this is also u sub n, that's okay. So here, your a is 2, your b is minus 3, though this is not u sub n, okay, this is not the same as this, but what is of interest to you is that it's u sub something, okay, and the coefficient is what you take as your b. So your b is negative 3. However, okay, take note, we said the u subs, okay, must be consecutive terms. So you have u sub n plus 1 and u sub n. So the question is u sub n plus 1 and u sub n, okay, are they consecutive terms? So let's see how you can generate your u subs. So I know that if I have u sub n, going forward, I will get u sub n plus 1. Okay, and that will also give me u sub n plus 2 as I move forward. Is that not it? If I move in this direction. I hope you are with me. Should
Yes.
I come again, or my point is well made?
Say, come again.
Okay, all right. So, okay, I'm just using the sub when we use letters. Don't be the letters usually, you know, we work with numbers. Okay, so letters, it means we are making it general. Numbers, it means we are making it particular. That's all. So if I have u sub 1, okay, if I'm moving in this direction, or let me even use, because I want to move more. So let me use, if I have u sub 3 or u sub 4 known, and I'm moving in this direction, the next term will be u sub 5. Do you agree?
Yes.
The next term will be u sub 6. Is that not it? So if I'm moving in this direction, I will be adding 1 to the sub to get my new sub. Is that clear?
Yes, sir.
Now, assuming I want to move in this direction, okay, you can see that your sub will increase in this direction and decrease in this direction. So if this is u sub 4, this will be u sub what?
3.
3. Okay, then before u sub 3 will be u sub what?
2.
2, as simple as that. So if I have my u, okay, sub n, okay, I'm starting, this is my starting, okay, u. Okay, before and after I should get other u's. So if I'm moving in this direction, what will be, okay, my next u sub?
U sub n plus 1.
Yes, you add 1 plus 1. What will be the next one? It will be this one also again plus 1. Is that not it? So it will be n plus 1 plus 1. So that will give you n plus 2. Jaffa.
Yes, please.
Okay, and if you move in this direction, that will give us u sub what?
N minus
N minus 1. So you decrease it by 1 when you are moving in this direction. So before n sub 1, u sub n minus 1, what will be the sequence? Sorry, the term. It will be n minus 1 minus 1. You keep on decreasing your known 1 by 1. So that will give you n minus 2. Afa?
Yes, please.
Okay, now if you know this, then we are going to have the work. Okay, so can I say that u sub n and u sub n minus 1, are they consecutive terms?
Yes, please.
They are. You can see they follow each other directly. Okay, they are not adjacent terms. Adjacent in the sense that there is no term between them. No term or terms between them. So if you look at this, remember we said the relation must connect two consecutive terms. So with this one, n plus 1, and u sub n, because the other term here is u sub n. U sub n and u sub n plus 1, are they consecutive terms?
Yes,
Are they?
please.
Yes, so it means indeed there's a recurrent sequence because the connection is between consecutive terms. If you come here, u sub n and u sub n minus 1, are they consecutive terms? You said yes.
Yes, please.
So it means this will also make this a recurrent sequence. Is my point well made?
Yes,
Yes,
please.
please.
Okay, now here comes something that now you are familiar. Okay, so I will just talk a little here. So note, the n term of a recurrent sequence is given by the formula. So it means even with the quadratic one, okay, you can treat that as a recurrent sequence, and that's what we did. Okay, so you use the same formula for the quadratic, okay, to generate, okay, your u sub n for the recurrent sequence. And we said u sub n will be equal to a plus s sub n minus 1, where a is the first term of the original sequence or the given sequence. And s sub n minus 1, we said, is the sum of the first n minus 1 terms of what? The sequence of difference. You remember where we just came from.
Yes, please.
Okay, so now, okay, you know all that we are going to do here. So it's the first part of the question that usually you use the relation directly. After that, okay, you know what you are supposed to do very soon. Okay, any questions at this point before I move on, my professors? So first of all, you should be able to identify, just as I told you, you should be able to identify APs and GPs. You should also be able to identify recurrence or sequence. Okay, so quickly, let's go and look at our first word example. All right, so at this point, I will call you one after the other randomly, okay, to answer the questions that we have here. If I call you and you don't respond, you are a suspect. Okay, determine which of the following is a recurrence sequence. So you have about 5, okay, sequences. You want to determine which one, okay, is a recurrent sequence and which one is not. Okay, so remember I said, if you want to determine, okay, recurrence in terms of sequence, we use consecutive terms. So check whether there are terms given, stated in the relation that you have there, okay, are consecutive terms. Otherwise, okay, what you have there will not be recurrent. So let's see. A, you tell me if yes, then you back it with your reason. Okay, no, you explain why no. So let me pick you or select, okay. Okay, let me see. Okay, ladies first. Prof. Mamiya, please unmute and say something. Okay, you've seen something, so say something. Prof. Mamiya, are you there? Mamiya, you know, if you don't respond, you are a suspect. I'll remove you and report you. So please respond. Prof. Mamiya, are you there? Yellow card. I will come back to you. If you don't respond, then the red card will come. Okay, Prof. Natalia. Inshira, let's go. Is it a recurrent sequence?
Yes, please.
Why?
Because U sub n is right after U sub n plus 1.
U sub n is right after.
No, U sub n plus 1 is right after U sub n.
So you said the opposite. Did you get it? Okay, so that's in actual fact, okay, U sub n plus 1 and U sub n, they are consecutive terms. All right, very good. Thank you very much. You've set the ball rolling, okay, in that positive manner. Okay, so let's look at the B. Let me see. Okay, now let me see if I can pick one of my guys. Okay, Kofi, Prof. Kofi. B, is it a recurring sequence?
No.
Okay, why?
Because after U sub n plus 1, we go U sub n. Well, no, the U sub n, after U sub n plus 1, before we U sub n, before you go to U sub n minus 1.
Okay, before. I want you said after and before. You use the two. You want to confuse me.
In U sub after, before U sub n plus 1 is U sub n. And before that is U sub n minus 1.
Okay, so it means between U sub n plus 1 and U sub n minus 1, there is U sub n. Is that not what you said?
Yes.
Okay, so they are not consecutive terms. Very good. Okay, well done. Okay, so the guys one, okay, the ladies one. So 1, 1, that's the score line. Okay, so let's see. Okay, another lady. Okay, so if I call you, please take notes. Okay, it means you are in charge of the ladies now, so they have their way in your hands, so make sure you don't disappoint. Okay, Prof. Antoinette. Okay, the C, is it recurrent? Prof. Antoinette, are you there? Please unmute and respond. Other than that, I'll put you in the same category as, okay, Mamiya. Prof. Antoinette, are you there? Okay, Prof. Victoria Asumeni, let's go.
Please. It's not, wait, it is a recurring
Hey, I heard not, I heard it is. Do you want to confuse me? Okay, so come again. Is it or it is not?
Please, it's not.
It is not. C is not.
Yes, please.
Okay, why?
Because the UN is coming before the UN plus 1.
It's coming before.
No, it is coming after.
After use n plus 1.
Yes, please.
Are you sure?
Yes.
A. Okay, the second penalty, okay, for the ladies missed by Victoria. Okay, Victoria, from N, where do you go to?
N plus 1.
So N and N plus 1 are consecutive because from there you move on to that. So this N plus 1 is directly after N, and N here is directly before N plus 1. So they are consecutive terms. You get it?
Yes, please.
Okay, what's your penalty though? Okay, so now it is what? 2. Okay, only that you play 2, scored 1, missed 1. Okay, for the ladies. Now okay, guys, let me see who I will call. Okay, Prof. Carl, let's go. The D.
It's a recurrent sequence.
It is.
Because and U and minus 1 are consecutive terms.
Okay, which one is before and which one is after?
UN minus 1 is before, then UN is after.
Okay, perfect. Okay, so 2, okay, 1. Okay, obviously the last one, we can't touch it. Okay, so the gents, okay, they had it. All right, okay, so let's see, maybe the next one, the ladies will be. I know definitely you talk. You are even lucky I didn't call you. Okay, so this is what we have. Okay, it means now you understand. Victoria, are you fine now?
Yes, please.
Okay, so this one, okay, so let me see if indeed you've understood. Let's do this one right here. Okay, now, Victoria, okay, let's see. Is this a recurring sequence? Convince me. I mentioned your name, so it means this one is customized for you. Before asking the question, so it's customized for you. I want you to convince me. Prof Vic, are you there?
Yes, please.
You are still thinking about it, right?
Yes, please.
Okay, all right. Who has an idea? Okay, so this is what you do. Okay, this is the trick. Take one of them. Okay, then check whether after, before, okay, you will get what you have here. So this one is n plus 1. After n plus 1, what will be the next term?
N plus 2.
Okay, who was that? Was that Aduma?
Yes, please.
Was I talking to you?
Sorry.
I knew I would get you. Okay, from Vic, let's go. No, I don't want to take your shine. Don't mind her. All right. Okay, so this is what? N plus 1. The next term will be what? From Vic. From Vic, can you hear me? Oh, what is happening? Victoria, are you there?
Yes, please. My phone was misbehaving.
Okay, all right. Okay, so we thank God. After n plus 1, which term do you go to?
N plus 2.
Okay, so which is not this. So let's see whether the term that is supposed to be before. So after before this, which term do you have there?
And UN.
UN. So the 2, any of them, is it this?
No, please.
So what can you say?
So it's not a recurrence relation.
As simple as that. Okay, so alpha. Okay, so just check. Pick one of them, then check. Go forward, backwards, and check whether you get the other one. If you don't get it, then it means they are not consecutive. That's all. I hope you get my gist.
Yes.
So, okay. All right. So now let's move on to, okay, the actual question. So let me do this. Okay. We know this one, we said this one is that not it? Okay. Was this one? No. Okay. This one, okay, is. This one, okay, is also. Okay. This one is not. All right. Okay. So now let's move on to, okay, our next set of questions. So we are going to look at proper questions, okay, and the recurrent sequence. So recurrent sequence, this is how the nature of the questions will be. Okay, it will always be loaded, okay, like this. Okay, it will be 1, then you have to do this and do that. Sometimes you'll be asked to find the S sub n. I've taken that one out. Now, because of constraints, they usually don't ask that one. They'll end here. So when you have time, I will walk you through that of the SN. It is more technical. Okay, so I will do that when time allows. Okay, so quickly, fasten your seat belts. Okay, and we are good to go. Let's go and look at, okay, the first one. So for each of the following sequences, U sub 1, U sub 2, U sub 3, U sub 4. Okay, given by a recurrence relation, find U sub 2, U sub 3, U sub 4. That is I. Then I, a formula for U sub n. Okay, so we are going to do A, I and I, VI and I afterwards, VI and I. Is my point well made? So let's take the first one. Okay, let's take the first one. Okay, at least if you're able to solve 2, okay, that would be okay, and your understanding is perfect. Then I know that this particular topic is also well treated. So solution, question 2. Okay, given U sub 1, U sub 2, you can choose not to write it, but you need this. So I'm going to go for A. A, what am I giving? I've been giving U sub n plus 1 is equal to, and when you are writing your sub, write it well to reflect, okay, like it's a subscript. Don't let it, okay, be too big. Okay, then that will be, is equal to 2 U sub n, okay, minus 3. Okay, comma, your n greater than or equal to, Prof. Karen, I'm coming, okay? Okay, and U sub 1 is equal to 5. Okay, now Prof. Karen.
It dropped off, so I don't know what you're doing right now. Could you please
Come
fill me
again.
on what, like, I dropped off when you were determining which of the following are recurrent terms. So I don't understand what you're doing here right now.
Wow. Okay, you try and follow. I'll bring you on board, okay?
Okay.
All right, okay, all right. So here, okay, we are giving this recurrent sequence, okay, and with this one, you are not supposed to test whether it is a recurrent sequence or, because the question told you that, okay, they are given by recurrence relation. So if it is not recurrent, it's not your problem. Okay, it's the problem of the person who sets the question, but we'll make sure that it will be recurrence. Is that okay? So you've been given this recurrence relation, you state it, and with the condition that you have there. Please, this is so easy. How do you find U sub 2, U sub 3, and U sub 4? It's so easy. At this point, I need your maximum attention. Okay, remember, you are told that n must be greater than or equal to 1. Okay, so meaning the n value should start from what? 1. Remember, we said n will start from 1, 2, 3. So if you know the starting point, okay, you should know where you are supposed to continue because your n will be integer values. So here the question is telling you that n must be greater than or equal to 1. So meaning you start from 1, then you move on to 2, what have you. So let's see. Here I am going to write if n is equal to 1. Okay, then I proceed. But as you mature, the if, okay, write it in your head, then you move on. So the first one, you know, as I always do, okay, it will be more of what, not the ideal way. Okay, just to help you understand. Then after that, I will assume you are mature, then you move on. So if n is equal, because the starting value of the n here is 1, just listen, it's not difficult, okay, especially the I. Okay, so what do we have? Okay, if n is equal to what? 1. Okay, we are going to get it. It means now the n here will be replaced by 1. So you get u1 plus 1 is equal to 2 u sub 1 minus 3. Remember, this 3 is not a sub. Is that okay?
Yes, please.
Okay, so this implies that u sub 1 plus 1, what is 1 plus 1?
2.
So it means u sub 2 will be equal to 2u sub 1. But what is u sub 1? The question said that u sub 1 is 5. So you substitute the 5. Afa?
Yes, please.
Okay, so which
Yes.
will be equal to 10 minus 3, which is equal to 7. All correct. All correct.
Yes.
Okay, so I am going to, so at this point, remember, you've not drawn your conclusion. So I think that's for this maturity there. We are all there, so we can do that. So let me clear this and write there for there. Okay, so now we are matured. We know we are looking for users. So therefore, so that we don't draw our conclusion. So let's go for the other one. If, okay, n is equal to the second value will be 2. Okay, you are going to get your n will be 2 plus 1. As you mature, I will do that mentally and write 3 there. Is equal to, okay, 2, your n is 2, so it will be u sub 2. Do you agree?
Yes, please.
Then minus 3. Okay, so therefore, u sub 3 will be equal to 2. What is u sub 2?
7.
7. Okay, it is here. Okay, so that will give you 7, then minus 3. So this will be equal to 14 minus 3. Okay, which is equal to 11. All correct?
Yes, please.
Okay, very good. So here, the thing is that anytime you are given a recurrent sequence, for you to get other terms, we have to give you a starting term value. So that's why a starting term value is given. U sub 1 is given. Okay, you need to know one of the terms. Other than that, there's no way you can get what? Okay, the other terms. So take note. So now the last one. And, oh, so I'm looking for I. So I should have written I here. So I'm solving for I. Is that okay?
Yes, please.
Okay, so okay, so at the point where I was going to write I will ask myself, have I written I? If I had not, then I'll go and fix it. So I would have cured that way, but thankfully I've done that before getting there. So, and when if n is equal to what? Okay, 3. Your u sub 3 plus 1 will be equal to 2u sub what? 3, then minus 3. Okay, therefore your u sub 4 will be equal to 2. What is u sub 3? That is 11 times 11, then minus 3. So that in effect will give us, okay, 22 minus 3, which will give us
19.
19. So we are done with A. Do you agree? Sorry, I. Do we agree?
Yes,
Yes,
please.
please.
Okay, so we are left with I. Our friend, okay, use up n for recurrent sequence. Okay, where we just came from. Okay, all right. So now let's go and look at I. Okay, because of space, I will need more space, so I will come down. Before I move on to I, any questions? My professors, are we all fine?
Yes.
Is everyone fine?
No, please.
Hey, no, were you whispering? I didn't hear you. Your no should even be stronger than the yes.
No, please.
Okay, so who was that?
It was Karen.
Karen. Oh, Karen is about to cry. Don't cry, okay? It is well. It is well. So where can I find you? In fact, where can we find you?
When I said that, I missed the introduction to this question.
Oh,
So
but
I don't know
even
where was the
whatever we
writing.
did, okay, whatever we did indirectly is not related before your line went off. Okay, because we were determining whether the relation that we were giving were recurrence relation or the sequence. And we didn't do that here. Okay, so because you were thinking that maybe there's something that I've said that's the more reason why you couldn't relate. Okay, please, I hope you are with me. Okay, whatever I did here, did I use, okay, what we did in the determination? I didn't, because we didn't determine, because the question itself told us that the relation is recurrent. So all that you need to know is, this is the question, we are solving this question. Okay, all right, so we are solving this question. Extract the relation that you are giving. And the question is I, we need to find u sub 2, u sub 3, u sub 4. And in the relation, you are told to start from n greater than or equal to 1. So your n will start from 1. So if n is equal to 1, just go and substitute the n into the relation formula, the recurrent there. So this will be 1. So that's what I have here, is n is equal to 1. I didn't do anything special, just substitution and simplification. So 1 plus 1 will give you 2. Karen, are you with me?
Yes, please.
Okay, then 2 u sub 1. The question gave you u sub 1 to be equal to 5. So you just
Okay.
substitute that one here. That's all. So save your tears for something better. Okay, not this one.
I was not crying.
No, I'm just pulling your leg. You know, like that's okay. I know how could I stay here like you? How could you cry? No, you can't do it. All right. Are you not shy of Mr. Akman that you cry? Okay. Okay, so now this is what we have. Okay, the rest will be treated in the same manner. So let's go and look at u sub n. Okay, so for u sub n, we need to know our sequence. So the original sequence, if you like, you can write original sequence or sequence. So let me, right? So the sequence that we are dealing with, you know, the first term, u sub 1 is what? U sub 1 is 5. That was given. Do you agree?
Yes, please.
U sub 2, we found it up to u sub 4. So that is what? 7, okay, 11, okay, 19. Then ellipsis. Is that clear?
Yes, please.
Okay, so now let's verify whether this sequence is an AP. If it's an AP direct, then we can find the formula straight away. For the UN, if it's a GP direct, we do same. So check whether it's an AP. Is it?
Oh, please.
Okay, it is not. Okay, obviously you don't have a common difference. Okay, you have a difference, but not common. Okay, is it a GP? Hello, oh, respond,
No,
then let's
please.
go. It is not. Okay, so neither an AP nor a GP, neither an AP or GP. So now, what do? We know where we are coming from. Remember we said, okay, if your sequence is neither an AP nor a GP, okay, the u sub n will be given by a particular formula. Is that clear?
Yes,
And
please.
even so, more so, you were told that immediately the relation that you have there is a recurrence relation. The u sub n will be given by that same fact. Okay, this is what I stated here. So for any recurrence sequence, the n term, which is u sub n, is given by a plus s sub n minus 1, where we started today. So we are comfortable with what we have here. But in any case, if you look at what you have there critically, okay, you will realize that indirectly we dealt with the UN of that sequence. Let's go back and check. Okay, have you seen? So we didn't do this. Remember, did we do this? We did
No.
it, right? Hey, we did A, then B. Then I said the rest along the line. Okay, in the subsequent, you see that you do it. So you can see that the sequence that we generated from the recurrent sequence is this sequence. So it's like now you've been given this sequence to find this. That's all. As simple as that. So when we do that, it means you should be able to do this. You get the point?
Yes.
Okay, so we are going to do justice to what we have there by, okay, subjecting that through whatever that we've learned, okay, today. So here we go. So this is not, okay, it's neither a GP nor an AP. So at this point, we have to go and look at the sequence of difference. Is that clear? Because we will need it. Okay, you know it will be A plus S sub n minus 1, but the S sub n minus 1 is with respect to the sequence of difference. So I am going to get my sequence of difference. So sequence of difference. Okay, in bracket SD or S dot D. Okay, so let's look at our sequence of difference. 7 minus 5 will give us 2, comma, 11 minus 7 will give us
4.
Okay, 4. Okay, comma. Hey, the next one.
8.
Okay, 8. Comma, then ellipsis. Is that okay?
Yes, please.
Okay, at this point, if you are writing, okay, stop writing. Okay, wear your seatbelt. Okay, fasten it and let's go. Okay, all right. So now we know, okay, that we can quote the formula. U sub n for a recurrent sequence is A plus what? S sub n minus 1. Am I right?
Yes, please.
Okay, but A is equal to is A, not Z. Okay, A is equal to, okay, the first term of the original sequence. The original sequence is this, is that not it? Okay, so that is 5. Okay, but we don't know S sub n minus 1. Okay, before we can find S sub n minus 1, we have to find S sub n. And the S sub n should be for the sequence of difference. Is my point well made?
Yes.
Okay, now determine the nature of your sequence of difference. Is it an AP?
No, please.
So it's a GP, is that not it?
Yes, please.
A GP with a common ratio of
2.
2. Okay, which is greater than 1. So you should know the formula that we are supposed to quote. Remember, I told you today that any of them will work anyway. You get it? But we'll quote the right one so that the negative will be catered for. For me, I have told you that I don't like negative. So anything that will help me deal with the negative at its initial stage, I will do so. Okay, so before it puts me in trouble. So, and I will need my S sub n minus 1. And before that, I'll write S sub n. So my sequence that I have here, I know this is a GP. Okay, so this GP, the formula will be A into R is what greater than 1. So it will be R to the power n minus 1 all over R minus 1. My professors, are you with me?
Yes, please.
However, again, you can see that the introduction of this A brings what, or introduces what? A conflict. So let's maybe use A sub 1 or A sub D, if you like, just to distinguish between them, that's all. Okay, nothing special, so that you don't get confused. Okay, so at this point, now I'm moving on to the next, okay, line. So it means my A here will be 2. My R will also be 2. Do you agree?
Yes.
Okay, so can I say that this implies that my S sub n minus 1 will be equal to, wherever I see n here in S sub n, I replace it with what? N minus 1. The A sub 1 will be this A, and your R will be the R, which will be 4 over what? Over 2. So by then you have done the test to determine that that's what. So you do that and write, this is what? A GP. Let me write it for you to know. So this is a GP. Okay, by then you have done your 4 over 2 is equal to 2. As your rough work, your 8 over 4 is equal to 2. So you get what? A common ratio. So you've done that, your rough work, you can strike it out. So now I'm going to get A, which is 2, into R, which is also what? 2. Do you agree? Okay, to the power n, but my new n is n minus 1. My professors, are you with me?
Yes, please.
Okay, then minus 1. Okay, so what I have here is only for this. Or you close it all over. Okay, now R minus 1 and R is 2. Okay, minus 1. Alpha.
Yes.
Okay,
Yes,
so
sir.
we are moving on to the next. So it means you can see that in the next, okay, situation, the denominator will be 1. So I'll write only the numerator. Is that clear? So my next, okay, I'm going to get S sub n minus 1 will be equal to, remember we said we are going to write only our new, because we get, okay, 2 into 2 to the power n minus 1 all over 1. Is that clear? But I won't write it. It's simply understood to be there. Is that clear? Hello, my professors. You are not responding.
Sir.
Is that clear?
Yes, sir.
Yes,
Okay. All right. So yeah, did you call? Did someone call? Or you said yes, sir. Okay, so now, obviously, again, we can't end here. Okay, let's remove the brackets. So this would be equal to, okay, this and this will multiply. Remember the indices. So the same base. So let me write it for you just for explanation purposes. 2 times 2 to the power n minus 1. Then this will be 2 times what? Minus 1, so minus 2. Is that clear?
Yes, please.
Okay, so we can write this as a single base 2. You know that this is to the power 1. So we are going to get 1, we add the exponent, plus n minus 1, then minus 2. So this will give us what? 2. Okay, then you get what? The 1 will cancel this 1. So to the power n minus 2. All correct.
Yes, please.
Is my point well made?
Yes, please.
Okay, so remember this is it for s sub n minus 1. You know your A, you now know your S sub n minus 1. So it means we know our U sub n. So therefore, okay, U sub n is equal to, okay, A, what was the A? Let's go back and check the value of our A. We stated then that is 5. Is that clear?
Yes, please.
Okay, so we get 5 plus our S sub n minus 1, and that is 2 to the power n, then minus 2. These two are like terms. Can we combine, right? So that in effect will give us 5 minus 2, which is what? 3, then plus what? 2 to the power n, as simple. Okay, so if you want us to verify, let's go to the original sequence, substitute the values of n and test for the first term, second term, and the third term. Okay, and see whether we'll get. So we are verifying. Let's do U sub 1. Okay, U sub 1 will be equal to, whenever we see n here, it will be 1. So it will be 3 plus 2 to the power 1, which will be equal to 3 plus 2, which is equal to 5. Am I right? Okay, so what is the U sub 1 for that sequence? It's 5. It's here. Is that not it?
Yes, please.
So let's do the second one. To the second one, we have to go and pick it from the other slide. So U sub 2 will be equal to 3 plus 2. Your n now is 2, so 2 squared. And that will give you 3 plus 4. Okay, and that will give us 7. So let's go and check whether the second term U sub 2 is 7. Okay, U sub 2, what is the sequence is 7. You get it. So you can try the rest if you want to. As I've told you, it's not necessary. Once you know you are on the right track. Okay, it's not really necessary. Point well made, my professors.
Yes, please.
Okay, so we are done with this question. So what will happen is we are going to end the class here. Okay, I will give you, your assignments will come later. I will give, it's likely I will give this one to you as your assignment. Okay, the B. So it means now we know how to find U sub n. If your sequence of difference is an AP, originally we did 2 of them. That one resulted in the quadratic. Okay, and just now you realize, okay, that if your sequence of difference is an it's a GP, okay, we can equally do that, and that's what we did. Okay, we can find the U sub n. Okay, so that's all that so we know how to deal with a recurrent sequence where the sequence of difference is an AP and where it is a GP, as simple as that. Okay, Prof. Abba Amamesa.
Sir, please, I wanted to know if so with what you were given, like the A, U subscript n plus 1, it's n always 1.
No, no, okay, you want me to untie the knot in your B. Okay, so check. Okay, see, with this one, you are told that n is greater than 1. Is that not it? Extremely greater than 1. So which integer do you have to start with?
2.
2. You get it? Because if you go and substitute 1, look at what will happen. You are going to get 0 here. Do you have U sub 0?
No.
No, so obviously you will know that it will not make sense. So the inequality here will guide you as to the n that you are supposed to start with.
Okay. Yes, sir.
All right, okay. So any questions, you are welcome. Any questions, my professors? Okay, Prof. Amma.
Sir, please, would there be a case where the terms will not be consecutive?
The terms will not be consecutive, as in?
Like a question will be given to us and
Are you
maybe
talking
we
about
realize that,
the relation?
yes.
Okay, that one will be beyond you. Okay, remember we said at this point we are looking at AP, GP, quadratic, the recurrence. Okay, we are not looking at any other. When I introduced you to that, I told you that these are the types of sequences at our level, in fact, at your level. Okay, so I won't give you anything outside that. We have this sequence. Remember when I mentioned the 4, I told you that that's not exhaustive.
Yes, please.
Okay, only that we are looking at the one within your domain. Okay. Okay, is everyone okay? We did only one example under this, but I think the explanation, the note is the difficult aspect is the use of n. And once we know how to ask for this one, it's just mere substitution for n is equal to, okay, the value of n that you are interested in. Then you substitute. So this one will give you you start from 2. So u sub 2 will be equal to 1 plus 2 into n minus 1. So it will be 2 minus 1. So it will be 2 u sub 1. But u sub 1 is given as 3. You substitute. Then you get your u sub 2. You do same to get your u sub 3, u sub 4. Okay, you look at the sequence. If it's an AP, okay, EP directly, and I can assure you, no recurrent sequence will be AP or a GP directly. So it's the sequence of difference that will come out of that. That will either be an AP or a GP. Then you know how to find or maneuver your way around. You are doing well, okay, provided you are not hiding issues. Okay, I thought I wouldn't be able to cover, okay, everything, okay, my target today, but you've done well, keep it up. Okay, please, okay, I will put assignments on the platform. If you need be and you need to, okay, wait for the video before you do it, seek permission, okay, so that you know, even if deadline beats you, you know, every assignment must be submitted, whether late or not, just submit. Okay, for me to go through, you won't see it marked, but it will help me address your concern whenever I am making the video of the solution. Okay, so on that note, okay, thank you very much. Elective math, we are done for this. Yes, my professor.
Sir.
I'm here.
Sir, please, so does it mean that for A, B, and C, you have to find U sub 1, U sub 2, U sub 3, and come and find for sequence of difference?
Yes, so the nature of the question is even guiding you.
Okay.
The nature of the question, you know, before I can find U sub n, if I know the sequence, I'm good to go. Or if I know S sub n, if S sub n is given, remember, we know that if S sub n is given, I'm also able to get the formula for U sub n. You get it?
Yes, sir.
Okay, but that one is for direct AP and direct GP. Okay, but what we are looking for, you can see that we didn't get a direct AP, a direct GP. It was the sequence of difference that gave us either an AP, okay, or a GP.
Yeah.
So once you do that, okay, you know that this is the approach to go. So you know U sub 1 is given, so you know you'll be able to find the 3, okay, more terms. So now you know your sequence. Once you know your sequence, subject it through AP, GP, but I've told you, it won't satisfy, the original one will not satisfy these two. So you have to generate the sequence of difference. This was the original one. Okay, so you come and generate your sequence of difference, and you investigate whether your sequence of difference is an AP or a GP. So we realize that the sequence of difference is what? Is a GP. Therefore, when we're quoting the S sub n minus 1, okay, which we will get it from S sub n, we are supposed to use this. We use this only to find the A, the first term, what we have here. And we use this sequence of difference to find S sub n and therefore S sub n minus 1. Then we come and add the A of this one to it, and that will give us the U sub n. That's all that we did. Is my point well made, my professor?
Yes, sir.
Okay, great. All right, okay, Prof. Lynette. Prof. Lynette, are you there? Your hand is up. Okay, Prof. Amma, your hand is also up.
Sir, please.
Lynette, were you the one that I responded to?
Sir, no, it's Prof. Samuela.
Okay, all right. So, Lynette, your hand was up. What happened? Okay, Amma, go ahead. Prof. Amma.
Sir, please, for the I, the conclusion, could we just first of all U2, U3, U4, then after that we'll conclude at the ending part, or if we like solve for maybe U2, when we finish, then we can now say therefore it is equal to this.
Yeah, so you can draw your conclusion individually. Okay, or as you can see, okay, the reason why I am writing the therefore here again, you can see that something has interfered. Can you see?
No, please.
No, something has interfered with this statement. Remember, I told you anytime you write but something is equal to and something has interfered with the therefore here because of this statement. So if this was not there, you get it? If this was not there and you were doing this, then indirectly you will know that you are writing. So at that point, you can write U sub 3 is equal to 2 U sub then, therefore can be there without writing it again. But because something interfered, I decided to write therefore here again, meaning I'm finding this. Therefore here again, I'm finding that.
Sir, please, okay, you have a point. But if maybe, I don't know, maybe something happens, then you can't really write it therefore there. Could you just write?
Issues. You want to imply that this first therefore is covering, okay, is paying the debt of the other two. Is that not what you are saying?
No.
So there is no therefore at all.
No, sir, look at A. Okay, so look at the second question. The second question, n is greater than 1, so we'll start from 2. So when we substitute 2 into this formula, it will be like if n is equal to 2, U2 will be equal to 1 plus, are we saying? We'll not write the therefore.
No, you can write the therefore there.
Okay. After writing if n is equal to 2.
Remember, I told you, unfortunately, we didn't do the second one. This is the first example, and I told you that as you mature, some of them you can take out. So you should remember I said, as you mature, if n is equal to 1, you should say it in your head.
Oh, okay.
So you straight away come and write, okay, n is equal to 1, because you know here I'm starting with 2. So I'll write, okay, therefore, U sub 2 is equal to 1 plus 2, then this will give you 2 minus 1. So I will write 2 minus 1. I'm matured to know that 2 minus 1 will give me 1.
Okay.
So I will get that one straight. So it means this will go. Okay, straight away. It is this that will come here directly. But I will write U sub 2 here instead of 1 plus 1. So if I was supposed to handle it maturely, this is how it should have been. Yeah, I will write the if. I'll write, okay, therefore, U sub 2, because I'm substituting 1. So this would be 1 plus 1, 2. U sub 2 is equal to 2. I substitute 1. So it will be U sub 1. Okay, then minus my 3. Then I'll move on and come and substitute, and I end it.
Okay.
All right. Okay, so that will be. However, if you are not mature, write the n is equal to, so that you know the n that you are substituting. That's all.
Okay, so thank
you. You are welcome. Okay, any further questions? All right, great. Okay, thank you very much. It has been a wonderful afternoon. With your contribution and everything, the class once again was a success. God bless us all. Okay, bye-bye.
Bye.
Bye.